Okay, let's talk about what we're going to try to do here. Going to be talking about how to potentially move the words from an inflammatory part of the space into a less inflammatory place. So we've got, I'm getting set up with a lexicon of inflammatory good and bad words using the Vader sentiment analysis. So let's see if I've got that. Here we go. Let's see. This would be, we'll call that lexicon. This is from Sentiment Intensity Analyzer from Vader Sentiment, the package. Let me show you the install for that. You want to pip install Vader Sentiment. That's in addition to the NLPIA package. If you've already installed NLPIA, you'll be good to go with pretty much everything we do here. And you don't really need this Vader Sentiment Analyzer. We're not going to actually use it as a package. We're just going to grab its lexicon of good and bad words so we can use those in a list of words that we can find that are on the opposite side of the world from the kinds of inflammatory texts that we're going to be trying to process. And I need to import spacey as well. I'm going to use that even though we're not going to use the word vectors in it. Let's do it from query. So we'll make sure we've got a decent tokenizer. Spacey, the word spacey stands for space because there are spaces between words in most cases. Spacey's a pretty fast and good tokenizer. But if someone could go out on the web and find some inflammatory title or sensational headline or clickbait advertisement that we can work with, something that has some positive and some negative words in it that we can turn positive. So I'll give you some examples of some of those words that we're going to be working with in our lexicon. We'll give you the bad words. Let's look at the 20 worst words in our lexicon. So words along these lines about villains and evil, and those are even pretty much worse than I was hoping for. We could even go for something heartbroken. Those kinds of words. If you find some of those inflammatory, scary words out there in the world, you can post them here in the chat, and I'll process those as text. So let's say that let's try something simple, something mild. I'm feeling sad today. And then we will try to find the negative words, and then we'll try to replace them. So this is going to create what's called a document in Spacey. Spacey has, and this has a vector built into it. It's the average of all the word vectors that are there. We don't need that one. We've got also from we've got a word vector object that is from the NLPIA package, which is what this talk is all about, the Natural Language Processing and Action book. So that we've imported earlier, we imported, from the loaders, we imported get data. And then let's just go ahead and do that just so you can see how that's done. And then we'll say word vector equals get data. And you can say word to vec, or you can spell out word to vec, and that will get all the word to vecs. The reason I like this a little better is it gives me a straightforward way to find individual words and to do similarity between individual words and do word analogy problems. That'll come in handy later. Also, it takes a little bit of time to load, though. You want to make sure you have lots of RAM. Let's make sure we're still doing okay. Oops, got a lot of RAM usage now. May have to close some windows here. Let's close my Gmail. That's not typically a good one to, that didn't help much. So it's probably because I've loaded the spacey language model. I'm right up at the top of what I can handle here. So I may have to look around. Anyway, we'll see how it goes. If I have to reboot, we'll reboot. So you want to, we'll just only load, we won't load any more language models. So I've loaded 2 large language models. As you can see in this word vector object that we loaded, it has an attribute called vocab, which contains all the words. So we've got, it looks like 3 million words in here. Spacey language model, the medium one, I think is the one I loaded. Let's see what its vocab looks like. I think it's like 20,000 for the medium. Oh no, that's right. But it does a clever thing where it only actually compresses it down to 20,000 word vectors. That's why I'm using the bigger one from Word2Vec. It has a lot of words that map to a combination of those smaller number of vectors. But anyway, we're going to be working with the more straightforward one, word vector, where there's a one-to-one correspondence between words and vectors. And we can look them up in word vector. Like, let's look up that word sad. First, let's just see if we can come up with a good word that's the opposite of sad, that's more closer to the other end of, that's the word vector. And now we can also, within that package, we can look for most similar, I think is what we're looking for. And we can give it, I think we have to give it a word. Yeah. Of course, we don't want to actually find words similar to sad, but but we will see. Ooh, and we don't want most similar. And we just had a crash because I got too much loaded. Let's see how our RAM is doing. Okay, we're back down to 2 gigabytes. So now I will not load spacey. Maybe I'll load a simpler tokenizer like NLTKs. So let's go back and start from the beginning. From NLPIA.data loaders. .loaders. Import. Get data. Word vector equals get data. Word2Vec. Okay, it'll take a few seconds. Then what we're going to do after that is we'll try to remember what the syntax was. I think I can look through the history of my previous. I'm going to open up another tab. Make sure, see how this is going. See how much of the RAM's being taken just by the word vectors. Those 3 million word vectors would take up quite a bit. Looks like it's almost done. Took a couple gigabytes, 3 gigabytes. Yeah, maybe that was the bad boy that was taking up so much space. Let's look back at our history. Let's work on query to get into that conda environment. And now let's bring up another IPython so I can look at the history. And let's look back for similar. Let's look back for other things. Most similar. If you give it a list of words, both positive and negative, it will find some words for you. You can do some math within Word2Vec. I can also show you how to, I'm going to also show you how to do that manually with the vectors themselves. So let's go back and see the word vectors have loaded. Great. Now let's do the most similar to, let's try that sad word again. We need to reload the sentiment analyzer. Let's see how big that one is. From data, let's see, try to find that. That was sentiment analyze. There it is. Let's look for that further back so we can find the import. There it is. So that's from Vader's sentiment, Vader.sentiment. Import sentiment intensity analyzer. Now we can create one, and now we can look at that lexicon. We need to import pandas. We'll also be using a lot of NumPy, so let's get that one in. Next, let's take a look at that. Let's turn that lexicon into a pandas series. It'll be easier to work with, and we can sort values based on the sentiment, whether it's positive or negative. And that's also, well, we'll just leave the full thing there and we'll just slice it. Let's create our own lexicon object, which is that series, lexicon. And let's look for some words. Let's see where sad is in there first. .loc, let's look for sad, just to see what its sentiment is. Negative 2.7, so it's going to be pretty far up the list, but we're going to look for words on the opposite side. So let's look at those positive ones, and then we'll be good to, let's see, let's look at negative, let's top 30. How about that? Positive words. Joyous, Lyle. Maybe that's some synonym for laugh out loud I'm not familiar with. Love, happiest, best. Good words. Okay, now let's talk about doing some. Okay, let's look at that sentence we had before. Let's just call it sentence. I'm feeling bad today. We'll use bad instead of sad. And then see if we can turn bad to good. So we'll say, we're gonna, and actually let's make it even easier so we don't even have to import any kind of tokenizer. Let's just put some spaces where we want. And so we'll make a doc that's just the sentence dot split. So now we've got a doc which has each individual word or token, and we can look those up in Word2Vec. So we could also do sentiment analysis on that. Let's see, what do we want to do? We want to find that that bad word. So let's see if we can, let's make a list of good words out of this glorious set of words on the top 20. Let's make it a little bit smaller. Maybe we'll skip every third word perhaps. Nope, that's not the way you skip. I think that's the way you skip. Great. Those look pretty good. Let's we'll put those into a list and we'll make some word vectors out of them. So good vectors. So it's going to be the word, the token, for token in lexicon, but we want to take the word vector for that. This could fail if those words don't exist. So give us yep, I'm going through the values, not the it's not the index. Let's see if I can do the index this way. Vectors. Let's look at the words. Actually, good words first. Make sure that didn't. Let's make sure that that's doing what I want. Because those vectors are kind of invisible to me at the moment. Let's see what those words actually are. Okay, good. We're on the right track. Now let's see if we can find. I was working on a function to see the most similar word. It had some bugs in it. Let's just do it to a single word first. Let's look back at all the ways we can do similarity with Word2Vec. Most similar by vectors. That's the one that worked for me well before. Let's try that. I've named it differently though. We call it WV. And we're going to say similar by vector. So we need to give it a word vector. let's find some words similar to bad, and then we'll find words similar to some of the other words. And let's see what this returns. This returns a two-tuple, so we can put that straight into a series. We can do it first, pd.series, and then we can say, we want to make a dictionary out of that first, and then make a series out of it, just like we did for our lexicon. And that looks like it contains the bad as the first word, so we probably want to take that out. We don't need, actually, let's just leave it like it is for now and see what happens. These are going to be the words that we're going to be looking for in our text. So this is going to be another set of words that we're going to include in it. So we're going to say bad words equals dot index. We could also have used that straight from our other lexicon. Let's see, bad words. Okay. No. Oh, interesting good is in there. That's no good. I'm going to have to stick with the Vader sentiment analyzer, because those words have similar sentiment. They're kind of talking about the quality of something. So word vectors don't have the dimensions that you might expect always incorporated into them. This is going to make it challenging, but I think we'll do just fine if we just use sentiment analyzer.lexicon, and we'll just keep those a bit hidden. We'll take the first, like we did before, we'll take 30. What did we do before? Oh, we did, yeah, that's right. We want to do the first 30 words. Oh, that's skipping 30, I think. I want to do 30 there. Let's see how that works. Lexicon. Let's see what lexicon is. Oh, we have it in our other lexicon. That's why. Because that's the one that's sorted. Ooh, got the values instead of the index. Good catch. Let's start with, so we have some bad words and we have some good words. Next, we need to go through our sentence. We have a document, I think. Let's go for word in doc. We were looking at that most similar. We wanted to do a quick demo of the most similar. Similar by vector, that's what it was. So it was word vector similar. Come on, give me a tab completion here. Help me out. Similar by vector. Well, we can do it by word. Similar by word. And we can use that word bad. And we can use the word today. Let's see. And now let's see which ones are similar to, let's see if this takes 2 arguments or only 1. That's right, I'm using this for the output after the math. So after we've added it, I'm going to use this to find some words, but this is going to be the last step. What we need is a way to perturb a word to make it better. So let's take the word vector for bad. And let's add the word vector from the last list of our lexicon, good words. And let's do that. Let's pick one word from there. Or we could find, actually we could try to find the closest word to that one, I think. But let's see what we do. That's right, I was working on that function. So I need to go through that list of Similarity. Let's see if there's a similarity. There we go. And let's see what it takes as arguments. Looks like it'll take words. Let's try similarity between good and bad. Sounds good. I think that's what it showed earlier. Yeah, 0.719, 0.719, cool. So now we can just do that between good and all the or bad, and a list of words. Let's see if it'll do that. Probably not. So we will have to do it ourselves. And let's give it our lexicon of our good word vector. We can just give it the words themselves. Good words. Okay. Let's see what's going on here. Let's see what those good words are. And we're looking for the words that are similar to bad among those, and there aren't any. That's good because we have a lot of low scores. So now let's take that word vector for good. Let's make sure we can use a vector in this function first. I think we're getting somewhere. Let's get this one here. Let's see if it'll take a word vector in addition to the actual string. Nope, it won't. Similarly by vector, probably. Ooh, this might be handier in the future. For now, we'll just stick with using the words. Okay, now what I was going to do, though, I need to perturb that and find the most similar. So let's say, the word vector, most similar. Make sure that's a thing. Yep. Positive. Make sure that's a thing. It is. Now we're going to give it some positive words, and we're going to say we're going to add some goodness, or we'll just add a whole lexicon of good words. And the negative. Let's see, we're trying to we need to also add to that our the word that we're actually trying to perturb. So we're going to add a bunch of good words to the bad word that we found in our sentence, and then we're going to subtract off some badness, perhaps. List bad words. And then we'll see what comes out as the most similar word to all this. Can only concatenate list, not stir. Of course. Let's see. So we got, they're not very close, but we do find some words that are, once we add a bunch of good to that vector, that bad vector, they're pretty far away, all these other words, but so most of these words would do okay in terms of substituting for bad in that sentence. So let's just take the top one from that list and let's see what happens.